Day 2 of 2.3 starts with a challenge problem. So I want you to put me on pause and try to solve this. Solve for C. Okay, how I would do it is I would start by distributing the 2/3. So 2/3 times C, which is 2/3 C. Then I have to take the 2/3 times the -18. So the -18 times 2/3. And then we still have equals 7. 2/3 C. -18 times 2/3, you can type that into the calculator and it'll work. I'm going to do this. I know that this 3 goes into 18 6 times. So this is -6 times 2, which is -12, equals 7. Now we have to undo addition or subtraction before multiplication or division. So the next step I would do is add 12 to get this, circle the C and the stuff with it. So 12 is not touching the C or the -12, so I have to add 12 to both sides. And you end up with 2/3 C still equals 7 plus 12, 19. Next step, I have to get rid of that 2/3. We can do it two ways. First, I could get rid of the divide by 3 by multiplying both sides by 3. That would cross off with that, and I would have 2C equals 19 times 3, which I believe is 57. And then I have to undo the 2 times C, so I need to divide by 2 to get rid of the 2. So my answer is actually going to be 57 is not divisible, by 2. So it would just be, these cancel to 1. C equals 57 over 2. And let's see if I'm right. Ta-da! We are. The other way you could have done it, when we were at this point where it said, so I'm going to go back to this step. It said 2/3 C equals 19. So we haven't talked much about the reciprocal, but the reciprocal of 2/3 is the thing that will multiply times 2/3 and give me a 1. So it's going to be, the reciprocal is it flipped over, right? Because this 2 reduces with that 2, this 3 reduces with that 3, and I end up with 1, which is what I want to end up with. So right here in the equation, instead of making it 2 more steps, I can multiply by 3 over 2 on this side, which also means I have to do it over here. 3 over 2. And the 3's and the 2's cancel, leaving me with just that C. And multiplication of fractions, you just multiply across the top. So 19 times 3, which was a 57, over 1 times 2, which is 2. So you get the answer either way. One is just one step faster. So what did we learn from yesterday? We learned yesterday that we should look at both sides of the equation. Is there anything we can combine? And this time, well, there is. There's 8 p's and 7 p's. So altogether we have 7 plus 8 p's, which is 15p, minus 16 equals 59. And now we're just going to solve it like we've been solving. Circle the variable and the stuff with it. And I need to move the minus 16 away. I have to undo it by adding 16. So I add 16 to both sides. I still have the 15p equals 59 plus 16 would be like 60 plus 15, so that'd be 75. And then I need to break apart the p and the 15. And right now it's not p plus 15, it's 15 times p, so I have to undo the times by dividing by 15 on both sides. That reduces to be 1p, so p equals 75 divided by 15 would be 5, right? 15, 30, 45, 60, 75. P equals 5. Let's see what else we have. You go ahead and try this one. Remember, if order of operations, you should distribute. So go ahead and try this one and put me on pause and then come back and you'll see my work. Okay, first I'm going to distribute this 5 because I can't do anything within the parentheses. So I still have the n plus. I'd have 5 times n minus 5 times 1 equals 7. N plus 5 times n is just 5n minus 5 equals 7. I have n's on the same side of the equal sign, so I can combine my n's. So I have an n there plus 5 more. I'm going to gather them all to me, and altogether I have 6 n's minus 5 equals 7. Circle the n's on the stuff with it. Move the thing that's not with the variable, so that would be the minus 5 to undo negative. I add. And you have 6n equals 7 and 5 more is 12. Now I have to break apart 6 times n. Undo multiplication is division. Divide both sides by 6. Remember to write it as a fraction bar. Those 6's disappear, and you get n equals 2. Hopefully that is what you got for your answer. N equals 2. So what's the solution to this? What are we going to do? I don't know how many of you like fractions. I do not like fractions. I think they're hard to work with. I can get rid of the fractions. I can find something that both 4 and 3 go into. So let's think of multiples of 4. 4, 8, 12, 16, 20. Let's think about multiples of 3. 3, 6, 9, 12. Hey, I think I have a match. They both go into 12. So I am going to get rid of those fractions by multiplying both sides by 12. So I'm going to take this whole thing, multiply it by 12, and this whole thing, multiply it by 12. So now I have 12 times 3/4 x minus 12. We have to distribute this, remember, times x, over 3 equals 12 times 10, 120. So this is multiplication, so you can multiply across the top 12 times 3. 12 and 12 is 24, that'd be 36 over 4x minus 12x over 3. Oh, sorry. Take that back. I lied to you. Hold on. We're getting rid of that. We could keep working with fractions, but we don't want to. If I multiply that by, we could have kept doing that, but if I multiply by 12, this 4 and the 12 are going to cancel out and give me a whole number. So actually, let's go back to where we were because that shows it. So this is going to cancel out. I'm not going to have 36 over 4. I'm going to have something goes into 36 evenly with 9. 9 times 4. So I have 9x now. This isn't 12 over 3. It is 4x. And I have still equals 120. I put it on, I took it off, but we're back to where we were. If I multiply by 12, I no longer have fractions. Yay. So I have 9x minus 4x. So I had 9 of them. You took 4 away. I still have 5x. Equals 120. And here I need to get rid of the 5, divide by 5, and you get x equals 5 goes in 120, 24 times. X equals 24. On to another one. All right, so this time we have 3 fractions we have to think about. What is the smallest number that 5, 4, and 2 both go in, all 3 go into? Well, let's see, 5, they're not going to go into. 10, 4 doesn't go into 10. 15, only 5 goes into it. 20, hey, I think we have a winner. I am going to multiply everything times 20 times 20. So let's write this a different way. So I'm going to have 20 times the 2b over 5. and I'm going to have 20 times the 2 over 4, and it's going to be equal to 5 over 2 times 20. Here's another way that you can do it. You can multiply the tops together, multiply the bottoms together, but I also can simplify here because I know 5 goes into 20 4 times, so I'm going to reduce this to be a 4. So now I have a 4 there. So now I have 4 times 2b plus, I know 4 goes into 20 5 times. So now I have 5 times 2 equals, I know 2 goes into 20 10 times. So 10 times 5, or 5 times 10. So if we write this, we have, well, excuse me, 4 times 2, 8b plus 5 times 2, 10 equals 5 times 10, 50. Now we're just back to the regular stuff. Subtract 10. Sometimes we circle this, right? So now we have 8b equals 40. 50 minus 10 is 40. And then we divide both sides by 8 to break 8 and b apart. And we get b equals 5. All right. You guys try this next one. So this is a 1. So we only need to find something that 7 and 14 go into and multiply everything times whatever 7 and 14 go into. Pause, give it a try, and then come back. They both go into 14. So again, if I have 14 times 2m over 7 plus 14, because we have to distribute it, times 3m over 14 equals 3 times 14. So 7 goes into 14 2 times. So now I have 2 times 2m plus 14 goes into 14 1 time. So I just have 3m times 1, which is 3m. And 14 times 3, 14, 28, 29, 30, 31, 32, 42. I'm not using a calculator. Please make sure that I'm right. All right, so this is 4m, 2 times 2m, 4m, plus 3m equals 42. Combine like terms. These are like terms. 4 and 3, how many m's? 7m equals 42. Divide by 7. And you get m equals 6. All right, let's try. Go ahead and you do this one, and Mr. Erlinson or I will check to make sure you're right. So you are actually going to try to do these two on your own and have us check. That is it. We should have a worksheet for homework.